Hey guys, just looking at our next lesson from our trig. We've been looking at trig ratios, sine, cosine, tan, SOHCAHTOA, Pythagorean theorem, looking at right angles. Today what we're going to be doing is we're going to be looking at triangles that are not right angles, and we're looking at the format as the sine law. Okay, so sine law is what we're using here. So we're going to be given a triangle. A, B, and C. Okay? Triangle, there's no right angles in this case. There's no indicated right angles. So what you're going to see at the top of your page here is you're going to see this triangle with an equation, and I want to show you exactly where these side lengths come from. Now remember, capital letters are indicated as angles. So what we want to do is we want to draw a line directly across and make the little letter A to indicate the side length across from angle A. Again, for B, I want to do the same thing. The side length across from angle B is little letter B, and the last one we have here is little letter C in this case, in this format. Okay, so those are some things we're looking at. And how to write this out as a proportion is writing it out as the side length all over sine A as the angle, B all over sine B as the angle, and little letter C as the side length over sine C. And that's the reason why they coordinate with one another. The side length of A goes across from sine angle A. Okay, and so what you're going to do is you're going to see these values in this format here and go through there. Today we're just going to look at side lengths. Today we're just going to look at side lengths, just a few examples, and I'll show you exactly how to do those. Okay? All right, with the first example with letter A, we're looking at our A, B, and C again. B, C, we're given X, 40 degrees, 60 degrees, and 32 meters. Okay, the first thing I like to do is I'd like to look at what angle coordinates with the side. And remember, angle C goes with side length 32, and that's what you need. You need to have an angle and a side length that go together that creates a numerator and a denominator as a whole. And that's what we need to figure out all the answers. Okay? So 40 goes along with X. So what I try to do is I always try to write out the full fraction first. So 32 is my side length all over sine 60. And then I write my X as my side length all over sine 40. Okay, remember the angles go with the sine function. Okay, the angles, not the side length, the angles. So at this point, what I want to do is I want to do my cross multiplying. So sine 60 times X equals my sine 40 times 32. Okay, so that's the format there. Now that's my setup. Now I haven't touched the calculator, haven't done anything with the calculator so far. What I want to do now is I want to get X by itself. Okay, X by itself. So by doing that, what I want to do is I want to take all of this in front of it and get rid of it. So how do I get rid of it? I divide it by sine 60. I do the same thing on the other side, divide by sine 60, and now I can place this in my calculator. Now, when you place this in your calculator, there's a few ways. If you have a dial calculator, you can just type this all the way in. So I can type sine 40 times 32. I can hit equals if I like, and then divide all of that by sine 60. And some of you may have to do that. Okay, some of you may have to type in the angle first and then sine afterwards. But if you're using a dial calculator, you can just type the whole thing in, and you're going to get your value of 23.75 meters. Okay, that is the format in that case right there. Now the next example. Next example you're looking at is obviously B, and we're given a triangle like so again, like here, and we're given 30 degrees, 70 degrees, and we're given 14 and an X. Now in both these cases, one of the key things we noted here was is that you're given one side and at least two angles. Okay, that when finding a side length using sine law, that's what you need. You need at least a side length and two angles. Okay, the two angles, 30 and 70, are provided for you. Okay, so those are the key things to note when using sine law for a side. Now, if we look at this and we put our arrows, the 30 goes with 14. The 70 goes with nothing. There's nothing over there that can work with the 70. So what I need to do is I need to pull an angle from up here that works with my x value down below. So if I add these, 30 plus 70 is 100. And I know in a triangle, I have to have 180 degrees in a triangle. So if I take 180, subtract by 100, I got 80 degrees left at the very top there. Okay? So another key hint here is the bigger the angle, the longer the side. Okay? It's just like how it opens. The bigger the angle, the longer the side. Okay? So think of that. So when I have 30 degrees producing a side length of 14, 80 degrees is going to be something larger than 14. Okay, so that's the key thing to note here. The bigger the angle, the longer the side. The smaller the angle, the smaller the side. Okay, so I put this together. 14 is the side length all over sine 30. X all over sine 80. Again, working the angles with the side length. Sometimes you're not going to have vertices. You're not going to have vertices A, B, and C, or 3 different letters. Okay? So then you're going to have to figure out, again, the angle that coordinates with the side. Do your cross multiplying. So sine 30x equals sine 80 times 14. Okay? Same idea as the last question. I divide by sine 30. I divide by sine 30, and again, working this out, you can take sine 80, and remember in degree form, your mode has to be in degree form here, times 14 divided by sine 30, and we get our value of 27.57. So x equals 27.57 as my value here. Okay, so those are the key things to note with our side lengths. Again, I cannot take the 70 and match it up with the 14. I can't match the 70 with the x. It's got to go directly across, and here there was nothing provided with that angle. Okay? All right. Let's look at some word problems. So the word problem you're going to look at below is giving you the question and looking at this in this format. So it says, 2 ships are 15 miles apart. So we got the SS Kira and the Victoria. Okay? They're 15 miles apart. All right? It says the Kira port to the port produces an angle of 55 degrees. And the Victoria has an angle of 45 degrees. Okay? And it says with respect to Kira, how far is the port from the closest ship? So again, this is kind of a trick question, but like what I just said before is, if this is the port that we're looking at, we want to find the closest ship to the port. And the closest ship is going to be the SS Kira right here, because it's directly across from the smaller angle. So that's got to be the smaller side. The bigger the angle, the longer the side. The smaller the angle, the smaller the side. So the SS Kira is the one we're looking at closest to the port. But again, we have 55 degrees going to nothing. Okay, so we got to find this angle at the bottom here. So that's the key thing, finding that angle. So 55 plus 45, and we're looking at, again, it's looking at 100. So we've got 80 degrees down at the bottom here. Okay, so that's again one of the things we're looking at, adding the 2 up, just making sure that we're looking at. So 55 plus 45, and again, that's 100 degrees. Same thing as what we're left over is 80. So this 80 degrees goes with the 15, matches up with it across from it. So 15 all over sine 80 equals x all over sine 45. And again, that's the angle that coordinates with the x. And also, we know that that x is going to be smaller than 15 because it's not as big an angle. Cross multiply, sine 80 times x, sine 45 times 15. Again, do the exact same thing like we've been doing so far and so far. And now we're going to get our actual side length, and we get our side length here. If I put this together, it's going to be 10.7 miles, or 10.8 that you might look at as well. Okay, so that's the key thing with that as well. So again, when you're creating these application questions, that's the big format there. Our last question we're going to look at here is the last one here, number 2 in the application. It says Zara and Rachel are 50 meters apart when they see a drone. So here's Zara. And here's Rachel. I know. Stick figures, I know. 50 meters apart. Zara sees the drone at an angle of elevation. Remember the angle of elevation? That horizontal line looking up to an object, 48 degrees. Rachel sees an angle of elevation of 27 degrees. And here's the drone. Okay, there's a drone flying, doing all that stuff. Way it is. It says determine the height of the drone. So the height or the altitude that we're looking at. Remember, the altitude creates that right angle at the bottom there. Well, we don't have enough information to find that height. We don't have enough information to find that height that we're looking for. So what we need to do here is we need to find a side length that we're going to use later on to provide us that height. So what I'm going to do is I'm going to look at across from 27. Okay? I'm going to look at the angle across, or the side length across, and make that x. Because I want to find that side length right there. Now, again, I got 50 right here. 48 goes to nothing. So what I want to do is I want to find this angle at the very top. So I take 48 plus 27. So 48 plus 27 is 75. 180 subtract 75 is 105. So this angle up at the top here is 105 as my angle. That angle goes with 50 meters directly across from it. So I'm going to find this side length right here. I'm going to find this side length that we're looking for right here. Okay, and I'll show you why. I find this side length, and I get 50 all over sine 105, and I get x all over sine 27. Cross multiply, sine 105 times x equals sine 27 times 50. Divide this by sine 105, divide this by sine 105, and I get my x value here. Okay, get my x value, and it is 23.5 meters. Okay, 23.5 meters. Okay, that's what I want right there. So once I found that information, watch what I'm going to do. I'm going to take all that information that I just gathered right here, and now I'm going to put it to use. I'm going to put it to use here, and I'm going to draw and erase all the information that's given. So now, what I want to know is the height. I now know what the x value is, and now what I can do is use my trig ratio. I've given a right angle. I can use my trig ratio. I can still go back to SOHCAHTOA. I know you just did that, but it still can be used here with a right angle triangle. So I take my 48. I see that is my opposite. This is my hypotenuse, and I have nothing at adjacent. So using my trig ratios, I can take sine 48 equals my opposite, which is my height, all over 23.5. And it's great because the variable's on the top. So I know once the variable's on the top, I can multiply. So same idea, cross multiply. 1 times h is h sine 48 times 23.5. And my height here is going to be 17.5 meters. So therefore, the drone is 17.5 meters in height. Okay, so those are the key things to look at from the lesson and provided for you. And then there's just a few other questions that I want you to go over and just fill in from there. If you have any questions, please give me a post. Let me know what's going on and go from there. Okay, talk to you later, guys.